at Infovista, and the presenter today is Eva Svanberg, Product Manager for Microwave and Backhaul Planning Tools at Infovista. As you all know, small cells backhaul is a hot topic. Everyone needs to have higher capacity in the network, and the solution for that is to add small cells. But all those deployments of small cells will not work without having a solution for the backhaul as well. There are several backhaul solutions for small cells out there. Since earlier releases, Mentum Ellipse do support point-to-multipoint planning for the lower frequency bands and non-line of sight planning for those. But in this release, with Mentum Ellipse 4, what's new is also non-line of sight planning for high frequencies, something that some vendors are heavily pushing. By these words, I would like to hand over to Eva, and we will see presentations and demos of how to plan non-line of sight the backhaul in Mentum Ellipse.
Hi everyone, my name is Eva Svanberg, as Astrid already told you, and I work as a product manager for Mentum Ellipse. And today's presentation is about the latest version, Mentum Ellipse 8.4, that was released some weeks ago. And I will start with some PowerPoint introduction, some highlights about recently released version, and also small cell microwave backhaul planning scenarios, and a small demo in the tool as such, and a summing up. And after that, there will be questions. I will start with a few words about Infovista. Infovista is a company founded in 1995. We have our headquarters in Paris, and the Mentum product was acquisitions in 2012 by Infovista, so that's why you can find Mentum Ellipse in the Infovista group. Mentum Ellipse had the name Mentum Link Planner 2, and Link Planner and Ellipse is from now on exactly the same tool. The Mentum product portfolio consists of 4 different tools. It's the Mentum Planet for the radio access, Mentum Fusion for automated network coverage management, and Mentum Ellipse for the microwave backhaul solution. And for all of them, we have a geodata group that can provide accurate maps for the different kinds of plannings in the different tools. What is Mentum Ellipse then? Most of you already knows what Mentum Ellipse is, or maybe already used the tool, but Mentum Ellipse is a next generation microwave planning tool supporting the entire mobile backhaul life cycle. It addresses point-to-multipoint and point-to-point wireless networks. You can also manage the logical layer of a backhaul and backbone network with all the available transmission standards with a transport module. You can do superior interference analysis and comprehensive data management in support of carrier-grade implementations. The benefits by using Mentum Ellipse is increased efficiency, because you can centralize the data management for efficient collaboration in between a lot of people at the same time. It's cost-effective, because it has advanced and reliable link design and assessment features that allows the engineer to cost-effectively define optimal wireless backhaul architecture. It has an unmatched accuracy that will save time, as well as allowing the engineer to aggressively push more data through the existing spectrum. You have the complete end-to-end solution for wireless access and backhaul planning, and also with Planet integration, the cell planning tool, so you get everything under the same roof, so to say. When it comes to the present version that was available from 1st of May, the Ellipse 8.4, I will go through the highlights here. If you want to have a detailed information about this release, I suggest that you visit our webpage, and there you can also download the release note with very detailed information about everything that is new in this version. First thing I want to highlight is the 3D viewer. In that one, you can visualize a city in a 3D model. You can move around and see it from any direction, zoom in, zoom out. You can visualize outdoor network coverage. So you can do a coverage diagram to see signal strengths in different areas. You can also visualize your microwave link, including the Fresnel zone, as you can see here up in the corner when you zoom in and zoom out. The vector building map is editable, so you can actually change the height on the fly in the 3D viewer, and we support vector buildings in MapInfo or shape format for this 3D viewer. The 3D viewer can also easily be opened from within Ellipse. You don't need to have any extra module or anything. You just need to have this vector map with building data, and then it can be opened and used for your planning to improve the accuracy of your analysis. In addition, it's possible to open any kind of web map in the tool, like Bing, Google, OpenStreetMaps, and you open that window in addition to your normal map window, so you still need to have clutter data, height data to do your planning. But in addition, you can open the same network and put the maps on side of each other to compare and move and find additional information in the web view. You can choose to look at the satellite or the map view. And when it's open here, it's actually like the real internet web map that you can see. So you use the Bing map features to zoom in, zoom out, etc. But if you move something here, it will move here and vice versa. But you can't use the height information, for example. You can import the site height elevation, but you don't use the height information model in the web map. It's taken from your normal elevation data. You can also do an address search. For example, if you have a site, then you can click on a small button and just get information about the address, the region, country, zip code, etc. You just click on yes, and then it will be imported, and you have that information inside Ellipse. You can also do the same with elevation height, import to your site. You can find the site in the web map, and you can also download OpenStreetMap vector data. So by using a feature, you download the vectors, and then you have an accurate vector data that you can use together with your clutter and height data within Ellipse. There are also some features not related to small cell backhaul microwave planning. We have improved the link analysis. First, we have started with the automatic channel allocation support that makes it easier for the user to assign frequencies automatically to a number of links. Earlier, sometimes it was a little bit complicated to understand the results, so we have included a new set of settings for better understanding and to improve the result. In addition, the user can now specify channels that will be excluded from the assignment process. Maybe you just want to use a certain number of channels in your frequency plan, then you can exclude some, and only the selected ones will be used in the assignment process. For the line of sight analysis, where you select a number of sites, you now have a search function. If you have a huge network and a lot of analysis performed, then it will be easier to find. There is a log window. These search functions, log windows, filter options has been added to a lot of analysis to make it easier to find a certain result. The reflection losses, if you have some reflection, earlier you could do that and you could see the reflection, but the loss was not calculated and added to the link analysis result. Now you can choose in the project settings if you want to include the reflection loss or not. And if you have chosen to do that, there is a specific section in the link analysis result report about the reflection, and that will affect your received signal level, your fade margin, so the availability will be different if you include the reflection loss or not. But reflection is very dependent on that you have accurate maps, of course. We have also improved the passive repeater, this old functionality where you are putting a back-to-back antenna to transfer the signal without adding any radio. In this passive repeater location, you can now have different antenna heights. You can have vertical polarization on the first part and horizontal on the other. And in the same way as reflection, the passive repeater information has been added to the link analysis report, and you will have a button here to click on if you want to see the result. If no passive repeater has been selected, nothing is displayed, of course. When it comes to usability, we have tried to improve the usage of the tool. So there is now a global editor for radios, antennas, feeders, and devices. You know, when you import a lot of radios or antennas, for example, you get a lot of information and it's hard to get an overview. Now you can open an editor for all your radios, and then you can just look at the different parameters, or you can edit, globalize for all of them at the same time if you want. This make the tool more usable, and you can also be sure that you are planning with the correct parameters. To make it a little bit more modern, we have added a ribbon menu option, so it looks like new Windows 8 or newer versions of Office or something. You can of course use the old look and feel, but this can be changed in the user preferences. We have improved search and filter usage everywhere, and 64-bit support, true 64-bit support, to be able to address more memory. This is best suited for users with very large projects with 15,000 or 20,000 objects in their databases. That will address more memory, so it will work. You can easily import via Excel, etc. But also the 32-bit application is much quicker in this version. And if you don't have a large project, don't use the 64-bit support, because it will actually be slower when you have a smaller project. So it's only for users with big projects that can see the improvement of addressing more memory. You have this option during the installation as such. Then we have the PointtoMultipoint module. It's not a new module, but I want to mention it here because not so many people has been using it before. But when it comes to the small cell backhaul microwave solution, it's sometimes needed to use this module. So you need to have that in addition to the traditional microwave core module. And with that, with the PointtoMultipoint, you can specify a distinct type of one-to-many connection, providing multiple paths from a single location to multiple locations. So you can have a mixed network with terminals. The terminals is like the access terminals, the radio terminals. Different users call it different things, and they are connected to a certain sector. So instead of having mobile phones out here, you have a fixed antenna pointing on a certain sector. And you have the PointtoMultipoint stations, or the BTS or RBS, that can be defined in the tool when you have this module. You can do terminal to sector connections, auto connection settings, link quality report, interference analysis. You can do any analysis in between terminals connections and normal microwave link connections, and you can do the coverage predictions. So what is new then in the PointtoMultipoint module in this release? We have a new propagation model called P3M, actually Planet 3D model. So it has been used in our cell planning tool for a long time, and it's ideal for small cell and endless backhaul because it takes into account free space losses, diffraction losses, building penetration losses, as well as clutter losses. So by using that one to investigate the area, you can get a quite good picture about where you have a good signal or not. This is a very good propagation model to use if you are using the sub-6 frequencies, the lower frequencies that traditionally has been used for solving no line of sight planning in small cell backhaul networks. But I will show you later on that we have an additional solution for that using higher frequencies. And this P3M model can be used for any frequency actually. There is also new templates, terminal template or base station templates if you're creating a lot of objects in the same way as you have template for a normal microwave links. You can do product verification exactly in the same way as you can do for a microwave. So that was the news. Of course there is more features than this. So to find out, please read the release note or visit our webpage. So small cell microwave backhaul planning scenarios, and here we are focusing on the microwave solutions when you don't have access to any fiber that can be quite expensive or very hard to do quickly. I think around 50% of the connections are done by fiber today, and 50% has to be solved with some kind of wireless solution. So why do we offloading to small cells? It's because of the capacity increase. The macro cells is not enough, improved customer experience and reduced cost. So there will be a lot of more small cells in the future, and all of them needs to be connected in some way. To help out in Mentum Ellipse to plan and optimize this, we have added the 3D designer that I have already showed you with the link and Fresnel display to easier find suitable connections in dense urban environment with this 3D map. We have this new advanced algorithm for the P3M module, and it's some additional features that is easy to use because they are very similar to normal traditional microwave planning. It's actually not so much difference at all. So what frequencies can be used then? As normal, the sub-6, but what is a little bit new on the market is that there has been trials done by different vendors that proves that they can use microwaves also in higher frequencies. And here we are talking about 20 to 42 gigahertz, the V-band around 60 gigahertz. And the advantage with this V-band is that in a lot of countries, not all, but most countries, this is a free band, which means that anyone can use it without any cost, without applying for anything. Not all countries, but most countries. And in addition, you have the E-band, 70 to 80 gigahertz. The advantage with that one is that there is a lot of free spectrum here, so you can get a lot of capacity. The drawback is, of course, that the Fresnel zone is very small because of these high frequencies. But when we talk about small cell backhaul microwave scenarios, we are talking about distances to up to maximum 500 meter, normally maybe 200-300 meter or something, and then it should be enough with those frequencies. We're talking about loose line of sight. The first Fresnel zone is free from obstacles, normal microwave planning. It's applicable in several cases also when doing small cells in the dense urban environment. You have the N-lows with a small n, near line of sight, which means up to 40% blockage of the first Fresnel zone. Then you can use any of the diffractions models already included in the tool. For best result, you should use any of the knife edge propagation models. And then we have the N-lows, which means no line of sight at all. For the sub-6 frequencies, normal coverage predictions with the PointtoMultipoint tool using propagation model P3M to find suitable connections can be used. For the higher frequencies, now we are talking about those shorter distances. There is actually three different scenarios that can be used, and that is diffraction, reflection, and penetration. And when you see those words, you recognize that it's traditional microwave planning, but you may not have line of sight, but still diffraction, reflection, penetration, nothing new. So you have the well-established methods to overcome the challenge with the location without a clear line of sight. They are already in the tools or in your guidelines, so just use your present knowledge. Also, point-to-point microwave is a cost-efficient technology for flexible and rapid backhaul if you compare to fiber. In addition, a microwave antenna do have a higher antenna gain compared to the antennas in those lower frequencies, but you can of course use them too. Both scenarios can be planned within Ellipse. You also have radios with a higher output power, and this gain and the output power will compensate for the high losses due to the N loss. And the only way that this works is because of this short distance. So the short distance in combination with high output power and high antenna gain compensate for the losses, because you will have a huge loss, but you will see later on also with those losses you have a quite good availability for more or less all modulations that you have. Also higher modulations, which means that you can support up to 400 megabit also with a no line of sight connection. You don't need, when you use reflection for example, you use the building walls as a repeater, so it means you don't need any extra equipment. You just need what you can find out there already, so it's no extra cost for that part either. So the first scenario, and now I'm only talking about the higher frequencies from 20 and up and not the lower one. That has to be solved within the point-to-multipoint module. So what do you need to do? In this case we have a macro cell up here, and we have a small cell down here and one here. And then first, and the small cells are on lamppost around 5 meters above ground. That is quite common, or some other thing or building or something, but quite low compared to the macro cells. First thing to do in the tool is actually to investigate if I do have line of sight in any way. And if I don't have that, and in this case from here to here I don't have it, by testing, it's a very quick test. I need to have some maps of course in the tool to do that. So next steps is to try to find a suitable location for a reflection point, and I use the maps, the coverage diagrams, the repeater functionality, the survey, and of course the 3D viewer, where I can also edit the obstacles if I don't have a 100% accurate maps, if I know that there is some error in the map, or if I have to do something, add a small obstacle or whatever, that can be done in the 3D viewer. After finding a suitable location for my reflection point, I can specify the reflection surface type and also fill in a loss. And after that I can calculate availability. So the different options for help is, this is the coverage prediction. So then I define my base station up here, the macro cell, and then I just select the signal strength in the area. Here you can see the coverage diagram and the different levels. So then I can find out areas where it seems to be a strong signal, so I can assume that I actually have line of sight. And then I can see this area here where it's pink, so it's a quite strong signal. And because of the house here, then I can assume that I have line of sight to the other side too. There is other features in the tool where you can select several sites to see if this line of sight in between, so there is a lot of investigation options. But when you see this, you can actually create this link and open it in the 3D viewer to see if it seems reasonable. And here you can see the macro cell, and here down you have my lamppost, and here I have the wall that I've been using for reflection. And in the tool, if it's line of sight, you can see green, and if it's not line of sight, red, or you can change to any color if you want to. At the same time, you can see the coverage prediction here on the ground with the different colors, and you can see the heights and the buildings and everything. So you get a very good overview over the area to see if this is a suitable location or not. When you have everything, here is another example where you have using this wall as the reflection point. Then you can open your link in the Ellipse, and you use the existing repeater functionality and the flat reflector. A long time ago it was quite common maybe to put up a mirror for very long distance link if you want to overcome a big obstacle somewhere. And we have actually used the same functionality. We have just added some extra information into the flat reflector window. So you can check, for example, compute surface, which means that the program will calculate how big area that is the first Fresnel zone that will hit the wall down here. So it means that it's 1.3 square meter, the size of the first Fresnel zone when the signal hits the building. So you know approximately how big the reflection area is. It's a little bit bigger, of course, but the first Fresnel zone is of that size when it arrives to the building wall. And you can check use building wall and choose what kind of material it is. Here we have added some options like glass, wood, brick wall, and there is undefined other. There is around 10 different options to choose between. We can add more material options, so if you are doing a lot of planning and if you are missing something here, just send a request to our support and we will add more material there. We are just waiting for suggestions from our customers. When you have done that, you have to type in the additional loss. Today is not automated, and the reason for that is that different vendors, different customers has been doing their own measurements, and it's not exactly the same everywhere, and we can't just put one customer's measurement losses here. So we have chosen to leave it blank. But I can say that glass is one of the best material to use, and it's around 3-4 dB, and brick is one of the worst one, up to 20 dB or something in loss, so something in between there. And in addition you can add some safety margin, extra 5 dB or something, so 5-10 dB if you have glass and up to 20-25 if you have brick, and wood is in between. So something like that, and that will be included in your as a loss in your link budget, so the received signal level will be affected, fade margin will be smaller, so availability will go down. The information about the flat reflector calculation can be found if you click on the result button over here. And you have a repeater section, so you get information about repeater to A, and from repeater to B you have the free space losses in the two legs. So it's exactly the same calculation as for any repeater functionality. The only thing missing is a mirror or a back-to-back antenna. You are just using the wall instead. This is one scenario to use reflection to overcome the obstacle and take a road trip around the obstacle, because in this case you have line of sight from here to here. It's very important that you have correct incident angle here, but when you use this functionality in Ellipse and move around, you will actually have the correct angle automatically, so you don't need to think about it. You have to go from up to down also, so that is like a straight line going from up to down when you find your reflection point. You can't go from up to down and up again. That will not work. The reflection will continue in the direction as it has started. But all those things can be easily solved within the tool. That was the reflection scenario. Another option to use if you can't find line of sight, that is the best option of course, is the diffraction scenario, and then you are using the edge of the rooftop. So in this case you have your macro cell here and you have the lamp pole down here, and the signal is actually blocked here, but because it's so close to the edge you need to be quite close. You can't be down here because then it's totally blocked and then it will not work. But if you go here, some parts of the signal will reflect against the edge of the rooftop and gives you quite good signal. You will have a loss here. It can be 20 dB or something, quite a lot. But still, because of the distance, the high output power, the gain, and everything. And in this case, you should use a knife edge propagation model. The triple peaks models, taking several peaks into account, will give a not so good result. And when we have compared with some live up running links, the knife edge propagation model has given very similar results to the measurements. And after doing that, you can look at the result and you can get the availability, and you get rain and multipass, and you can see also for the highest modulation is very good availability in this case, even with the loss taken into account for this diffraction edge. When you design small cell and plan backhaul, you can't start in Ellipse. So whether it's wireless or not, line of sight, no line of sight, point-to-point, point-to-multipoint, we cover all the needs with Ellipse and Planet. So the initial stage you have to do in Planet, but we have an interface so you can easily import the location of the small cells into Ellipse to do the backhaul part. Some coverage predictions, especially for the sub-6 frequencies, can also be done in Planet, so it can be done in either of the tool. But you can flow in between and get quite good and accurate result. Okay, I have the questions, but I would like to open the tool as such before we take the questions, just to show you very quickly how it can look like before we are ready. And this is an area in Chicago downtown, and I have created a very, very small network with base station up here. And if I want to, I can click on the base station and start point-to-multipoint analysis. Before doing that, I need to do some settings, of course, select propagation models, distances, resolution, and all those things. But I have cheated a little bit, so it's already done. And now you can see prediction here with different colors. And then there is a legend, so you can see the colors up here, so it's quite good signal strength. So in the areas where you have this signal strength, where it's pink, it's quite a strong signal. And if you want to see a little bit better, I can do like that, so you can see the signals. So I would just like to show you how you can investigate if you want to use, for example, the reflection case. And I want to go from here down to here. So I create a link and I start from here. And then I just move down to this one and click here. And then I have my link, and you can see it's a bad one. It's totally blocked. I can't use diffraction. I can't use anything. So I would like to try to use the reflection scenario. And if I put back the imagery so I can see a little bit better. So this is a house, and here you have a house too. So I would try to use any of the houses And here I have put automatic so I can see the height of the houses because I can't use a reflection point that is higher than the house. So I open my link, and this MV Link 3, and I go to the repeater functionality, and I click on the button here, and then I can move around, and then I can see if I have a suitable location, and it seems like I can use this wall here. So I click there, and I click on Add, and then I have my location. But of course 30 meter is a little bit high, so I have to use a lower, so I have to change to the flat reflector first, and it's, let's say that it's 6 meter, and then I change the tower height also because I don't have a real tower height. It's just the reflection point. And if I like that, I have to assign a frequency also so I can see the Fresnel zone when I look at it in the 3D viewer. So I just click on Save, and then I open the 3D view that I was talking about before, and then I need to have my map window open, and I go to the GIS New 3D Window, and I click on that one, and then I will have my result here. And then I can use the mouse just to move around and zoom in and zoom out. And let's see if I can find my new link somewhere. Not so easy sometimes. So here it is. So then you can see it's green, it's go down here and up here, and it's quite good. And I have the coverage prediction in the bottom, so then I can assume, okay, this is a good one, this will work. I can also click on a building here, and then I see the above ground level height, and I know, okay, this is much bigger, so I type in 30 meter, and then it grows up like this. So this is an easy way to change the height of a building that I know is not correct. So if I go back to this one, I have to click on Save, then I can click on the Results button, and then I can see the availability for everything, and here is 100%. And I've forgotten one thing, so I have to use the building wall, compute the surface, and I choose brick wall and a 15 dB, and click on Save, and that will affect the result. So maybe it's a little bit worse now. We'll see. So I click on that one. It's still good even if I have this big loss. My results I can export to Excel, to PDF, or whatever. If I instead want to use diffraction, then I can just open that link. I can do the planning. I have the results and everything. And I talked about the 3D viewer, not the 3D viewer, the web maps earlier. So they can be launched from the GIS menu too. So I just select New Web Browser, and then it appears. And I want to see it at the same time as my map window, so I do like that. Okay, and I don't want to see the microwave link, and I don't want to see that one, and I don't want to see that one, but I want to see that one. And here I have to use the features down here, so plus. But if I take this site, for example, up here, and if I move that, so do you really want to move? And I say yes, then you can see it moved in this direction too. So this is a way to get another view compared to this one that will help you in your planning. So I think I'm pretty done there. So if you have any questions or anything.
Thanks, Eva. I've got one question here that is actually asking about the penetration use case. If you can say a few words about that.
Okay, for penetration, you use Now I don't have any example here, but if you have a single knife edge or a small building or a tree or something, then it's just to do like you normally do. You select the knife edge method and calculate the loss. We don't have a specific foliage loss yet, meaning when you have going through sparse trees or something, because it will be a less loss than a solid loss. That will come in a maintenance release later on. So today you have to use the loss that you get from a solid area, and that's quite often a bigger amount of loss than the other one. So that works very well too, if it's just one obstacle blocking.
Okay, we have another question here, and that's about the reflection. I understand it's how do you ensure that the incidence angle is okay so that you actually get the reflection?
The incident angle is automatically correct. It will be the same from both directions. When you move the cursor in the tool, you can't get the wrong one. It is the correct one wherever you move. It will not be possible to move to a point without having the correct one, so it's automatically.
Okay, another very interesting question is more on the implementation side. And one concern for the non-line of sight microwave planning is the implementation of the antenna alignment, the orientation of the antenna. So how accurate is the tool in terms of the received signal loss, which is being used for the field tech to orient the antenna?
You can automatically align the antenna, and you can align it against the middle of your reflection point, and that will be automatically, and it should be quite accurate. And in your tool you can see the azimuth and the tilt, and you also have again relative maximum gain, so you get both relative north, and so it should be quite accurate.
Okay, I think that we will go to the next question. It says that for the long line of sight there will be a signal loss in addition to the free space loss. But does that mean that the need to use lower fade margins?
If you have an additional loss, you can add any additional loss, but I mean you can't have, you must have a fade margin still. But I don't know what you mean with lower fade margin. You still need to have a fade margin that is big enough so that you have a good availability. But there is a possibility to add this extra safety loss or whatever to compensate for this no line of sight. But you still have you must have a fade margin.
Okay, thanks for that answer. In the 3D viewer, there are building elevations, and we had questions here about these 3D buildings where you can get that kind of data, and Infovista is able to provide that sort of data, and in many cases it also is used within the RF, the cellular planning departments. And it's actually asking if the elevation are taken automatically from the geodata or if they need to enter the data itself.
Yeah, the elevation is taken from the geodata automatically. When you are setting up a project, you need to have the clutter land use data and elevation data, and in addition, if you want to do this accurate 3D view, a building data in vector format. But you are selecting that in your project settings, and automatically later on when you create a site to do something or do a path profile or any kind of analysis over the area, all those sources are taken into account automatically.
Here's a question, is whether you modify the height in the 3D view. Does that mean that you modify directly in this data, or how does that work?
When you modify in the 3D viewer, you have what we call user data, and you can also edit in the vector map directly as such, and you get user data, and then you can add that data into your building data as a separate layer. It will be a separate layer, but it will be taken into account at the same time as the other one.
Okay, we had another question here is about passive reflectors for long links, which is a bit different, but 30 kilometers and up. It says, can you please confirm whether this tool is fully developed to deal with passive reflectors for long links?
Yes, you can use a passive reflector for a long link. That's doable, yes. So no problem with that.
We had a questions about adaptive modulation as well.
Yes. Yes.
And can we plan adaptive modulation in Mentum Ellipse, or is actually a question about can we plan adaptive modulation in Mentum Link Planner? And then I would like to repeat that from this release 8.4, all versions of the project will be called Mentum Ellipse.
Yes, and you can plan adaptive modulation in older version of Link Planner, newer version of Link Planner, newer and older version of Ellipse, and of course in the latest one. And you have the adaptive modulation here. So all the examples that I have showed you has been using equipment with adaptive modulation from this lowest one up to this highest one to show different availability in the different capacities for the different modulations. So that's fully supported.
By that, I think that we will need to end this question and answer sessions. I would like to thank everyone that has attended this webinar regarding Mentum Ellipse 8.4 and planning of small cells backhaul, especially non-line of sight links on high frequencies. Thanks to you, everyone.
Thank you.